Hello guys, welcome to the Math Journeys. I'm Alan Ramos and this is my second video about dealing with math and in the next few months I will be creating a video for algebra and trigonometry. But before we tackle about algebra and trigonometry, let's go to the basics. Now, one of the basic topics that before a prerequisite to algebra is how to classify real numbers. Real numbers have different subsets. They have different classification. And to start off, the one the the lowest classification of a real number is what you call natural numbers or counting numbers. Counting numbers is just the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth, as long as you can count them. So that's the first one. So natural numbers is a set of numbers such as 1, 2, 3, 4, and 5. Now, if you go beyond natural numbers, you need to there's a notion that there is a need for null you know noneness or having none, so that you can be expressed to zero. Now if you add zero to the set of count of numbers, you get whole numbers. These are whole numbers. So sample numbers are zero. The set of whole numbers are 0, 1, 2, 3, and so on and so forth. So those are whole numbers. Now, in a bigger subset, you include 0 and 1, 2, 3, the positive numbers, but there is an opposite to the positive. And those positives are called negative numbers. So you have -1, -2, -3, -4, and so on and so forth. Now, if you include whole numbers and their negative side and their negative signs plus 0, that's what you call an integer. So an integer includes -3, -2, 1, and so on and so forth. Now, going going further is that you can you can express an integer into a fraction, and that's what you call a rational number. So a set of rational numbers. A set of rational numbers is m over n, where m over n are integers. So these are integers, but n must not be equal to 0. Now, the denominator cannot be equal to 0 when you express rational numbers, and can be expressed as a fraction. There are two types of rational numbers. Let's look at them. The first type is a terminating number. A terminating number is a fraction that's at a terminating decimal. For example, 7 over 4. So if we divide 7 and divided by 4, we get 7 divided by 4 is 1, and 1 times 4 is 4. You get 7 minus 4 is 3. So you get 3 here divided by 4 cannot be yet, but you can subtract 3 by 0 and add a decimal point, and it becomes 3. Carry down the extra zeros here, and it becomes 30. 30 divided by 4 is 7. 7 times 4 is 28. 28 divided by 30 minus 28 is 20. 20 divided by 4 is 5, and 5 times 4 is 20, so you got a remainder of 0. If the remainder If you get a remainder 0 at the end, after you put the decimal point and you try to compute it like this, it's a terminating rational number. Now there are repeating rational numbers such as 1 over 3. And what happens to that? So let's divide 1 by 3. So 1 divided by 3, that's, you cannot divide it by 3, but let's minus it to 0 and add 0 and a term decimal point here, and you carry down 0 here to become 10. 10 now divided by 3 is 3. 3 times 3 is 9. 10 minus 9 is 1. Carry down 0. 10 divided by 3 is 3 again. And then 3 times 3 is 9. 10 minus 9 is 1. Carry down 0. 10 divided by 3 is another 3. And 3 divided by 3 is 9. 10 minus 9 is 1, and then carry down 0. But as you can see, the numbers are repeating. So when you denote a repeating number or a repeating pattern, you just put a bar sign at the top, or you can say 0.333 and then 3 dots to say that this is a non-terminating rational number. So repeating numbers are non-terminating rational numbers, while terminating are terminating. So let's have some exercises here. So let's start with this. Can you express these integers as a rational number? Remember that we talked about a rational number. An integer is considered a rational number because you can express them as a fraction. Now, if you want to express them as a fraction, it's like 7, and 1 divided by 1 is just 7. So this is it is now expressed as a rational number. Same thing with 0. 0 divided by 1, it's m over n. Well, as you can say, n is not equal to 0, and negative 8 is just negative 8 divided by 1, still m over n. Well, n here is not equal to 0. Now, let's move on. Can you classify each rational number as a terminating or repeating? Let's see. So, in this number, we're going to classify them if it's terminating or not terminating. So 5 divided over 7 is considered terminating. Sorry, it's considered repeating number. Because if you divide 5 by 7, you get 0. And you bring down 50. 7 divided by 50 is 49. 49. 7 times 7, 49. That's 50 minus 49, 10. So 10 divided by 7 is 1. 10 minus 1 times 7, 7. 10 minus 7 is 3. Bring down again the 0. 30 divided by 7 is 4. 4 times 7 is 28. 28. And 30 minus 28 is 20. 20 divided by 7 is 2. 2. And then 2 times 7 is 14. 20 minus 14 is 6. 6. Carry down again the 0. Drop the 0. 60 divided by 7 is 8. 8 times 7 is 56. 60 minus 6 is 40. And 40 divided by 7 is 5. 5 divided by 7 is 35. And it seems that I'm back at 50. So if I do 50 again, it would give me another 7. And looking at that, this gives me another 1. So it's a repeating decimal. So I just put a bar on 714,285 because it's a repeating decimal. So this one is a repeating decimal. For letter B, it's a terminating decimal because if you divide 15 by 3, that's 5. 5 times 3, 15, 0. The answer is 5. So it's terminating because it's not repeating. How about 13 divided by 25? So 13 divided by 25, that's, you can't divide it, so you add 0 and a decimal point. 13 minus 0, you get 13. 13 divided, and then bring down 0. 130 divided by 25 is 5. That's 125. 10 minus 5, sorry, 130 minus 125 is 5. Bring down again 0. 50 divided by 5 is 52. So it's 0.52. So you have a terminating decimal.